There we go. Howdy, everybody. Welcome back. For our next speaker, we welcome back Adam Rosien, who is going to be introducing us to I don't know driven development. Adam, take it away.
I don't know what to do. Okay, let me share my screen. Okay. So I think that's big enough. Give me a thumbs up if it's legible. If it's not legible, give me something else. Happy to make it bigger. This seems great. Okay, lots of thumbs up. So this is a lightning talk, so I got to talk fast. But I'm gonna do it no problem. So this is sort of a technique that I use when I'm programming, and I sort of didn't have a name for it, so I made up this term, I don't know, driven development. And so this comes from my example that I'm going to use comes from a blog post I wrote in 2017. Woo! Which was about like this the same idea, and it was sort of called it type Tetris. You might have heard that thing. And so the example that I'm going to walk through is we want to create a service that reads a request and produces a response. So pretty, normal. And the request needs to be authorized. You have to pass some credentials and only do the work if the request is authorized. And you should do it asynchronously, or there's more and more requirements we can add on. But this is sort of what we're going to use to sort of describe the technique. And you probably use some of this technique. So here's my code, and it's it's updated to Scala 3. Yeah, go me! And look, I'm using Scala CLI, and I'm using the type level toolkit. Yay! And everything just works. I can import cat's effect because I'm going to use some concurrency, and so here we go. So one thing we can start with is, okay, well, our basic requirement is we have a service, and we have it takes a request and produces a response, and I'm going to do it in I/O because it's going to be asynchronously provided. So you'll notice that, like, I don't know what I'm doing. Like, I don't know. So I have these abstract types. I just say, I make what I'm starting to do is I'm making a signature for that represents what I want to do. But I don't know what the request type is right now. I don't know what the response type is now. So I can just make those abstract. Like nobody knows. Nobody knows what they are. So that's one way of saying I don't know, is you make an abstract type. And then another thing we can do is, well, if I have the signature, this is the thing I want to produce. This is my goal. And it has some types, and either of those types are abstract or concrete. How do I implement it? Well, the first thing you do is you say, I don't know, with these triple question marks. I use this all the time. And in case you're wondering, if you can go into it here, this is provided by Scala itself. And it kind of says exactly what it's used for. A triple question mark can be used for making methods that remain to be implemented. So it's not implemented yet. And it has type nothing, which is it has no values. So you could never produce a value of type nothing because there are no values of type nothing. So that's why it's good to return nothing, because you can never do it because you don't know yet. And we could even say, instead of using nothing, you could even say type I don't know is actually nothing. And maybe we're in Scala 3 and we want to be fancy, we can say, oh, we're going to just make it an opaque type nothing. So if I don't know yet, I could even do like, I don't know, and I don't know. And nobody can actually call service with something. Maybe it's a string. And the compiler will say, it's compiling, and it says, I found a string, but I want you to produce an I don't know, because we haven't defined I don't know yet. So the compiler is going to help us out. And I'll just leave that. So instead of saying I don't know, I'm going to use the request and the response. So when okay, we have some instructions. You know, we've done this. We have our skeleton. That's our signature, our type signature. So we can sort of make that equivalence. Okay, here's our skeleton, and it's the signature. And we need to request the request needs to be authorized. So what do we do? Well, I don't know. So let's maybe we need to authorize the request. And then the compiler is going to say, I don't know what that is. There's no authorize. So what do? Well, we define authorize. And it's going to take a request. And I don't know. Maybe it's going to authorize a request, so it's going to return another request. That's maybe it's authorized. And how do I do that? I don't know. And now we get some feedback. Well, first of all, that authorize does not return the response, and we sort of know that already. So that's okay. We're gonna get a new request, and then we're going to pass it to the handle authorized, and the compiler is going to say, I don't know what that is, so handle authorized. And it's going to take a request. This is going to be like our real thing, and it's going to return an IO response, and I don't know how to implement it yet, but I know that I can do this. And there we go. Everything compiles, so we know we're on the right track. So we have an I don't know how to authorize. I don't know how to actually handle the authorized request, but I know that I need to do this in this order. I first authorize, and after I authorize, I handle the authorized thing. Okay, so we can notice that, okay, well, this signature says I want to authorize a request and get a request. So maybe our request type needs to be more structured. So maybe a request is not an abstract type. Now we can start being specific. We could say that this is an algebraic data type. So we can use an enum. And what are the cases? Well, my request can either be unauthorized, or it could be authorized. That sounds like the right track. I don't know, but that's maybe what we should do. And when I get my request in my service, I'm not going to get a generic request. I'm always going to get an unauthorized request. And so my authorize function is going to take an unauthorized request, and maybe it's going to produce an authorized request. Wrap. There we go. So we have a bit more structure now. Okay. And we have our placeholders that we know we need to oh, I'm halfway through. All right, we have all these ways to do it. So then, okay, I go part by part. Okay, let's concentrate on authorization. Okay, I have an unauthorized request and I produce an authorized request. Well, that's not exactly right, because what if my authorization fails? So then when we think about, okay, there's failure, and we can model failure in lots of different ways. Perhaps the simplest way would be I return an option of authorize. So if I fail to authorize, if I succeed to authorize, I return a sum, and if I fail, I just return a none. So that makes us gives us some red squiggles, and we can say, okay, well then I handle my authorization, and I get back match, and I can use my thing, and we can say I don't know what to do, and I don't know what to do. Well, if I'm authorized, I'm going to get my authorized request, and then I know that I can handle my authorized request with my authorization value, and I know that my handle authorized will only take an authorized value. So I'm just filling in. I'm just going step by step here, and I'm using the compiler to give me some red squiggles to know if I'm on the right track. And some things, I haven't worked on my response type yet. I haven't handled my, I only do the work if the request is authorized. Did I fulfill that? Okay, well, yeah, I did. I'm authorizing, and only if I'm authorized can I do this. But I still haven't, I can look through my code and I can figure out, okay, well, what cases haven't I handled yet? I mean, I could just leave it blank and the compiler will will say, oh, something's not right. There's no code here. You know, oh, you forgot to implement it. But you know, I can just look for the, you can perform a little syntactic analysis and say, are there any triple question marks? Okay, then something must be wrong. And so we can just do some sort of implementation, and we can say, okay, if my request, well, it doesn't have any properties, so my unauthorized request, well, maybe it's we're in a fancy world and we have some magic token that I pass in that I've got from my phone or something. And so if my token is the magic value, then I return some requests not authorized, and otherwise I return none. So maybe that's our really fancy authentication scheme. And so now I want to say, okay, well, what do I return in the case if I'm not authorized? Well, I have a choice. So I could either model my failures to authorize as a response type, or I could fail the entire IO. I'm going to decide to just make the response type a bit more structured itself. So I'm going to make another algebraic data type, and my response is unauthorized in case you know, the authorization fails. Otherwise, I have a I don't know, success, which has some value inside of it that I don't know yet. I don't know what's going to go in here. So here I'm going to return a response unauthorized. Can I just do that? I'm still learning Scala 3. No, I gotta do that. And so on and so on. So this is the basic technique. Let's see, what did I do? Oh, well, I need to turn this in an IO, so IO here. To summarize, we can use two sort of syntactic techniques. One is we use this triple question mark. So anytime you don't know, well, first of all, you sort of write what you want. And you know what you want is like, this is the abstraction. You're creating a function signature or a type signature, and you're saying, this is the thing I want. And to provide a value, I need to implement it. And if you don't know what the value is yet, use the triple question mark and then fill it in later. And then sort of that's at the value level, you know, it's a computation level. And then at the type level, you can use abstract types. We started with some abstract request and response types. And then you slowly fill in more and more structure. So you can, the best way to do it is to create algebraic data types. In Scala 3, you can use these enums. Scala 2, you can use sealed traits and case classes. And, you know, we do the same thing when we're writing code. We know we want to do something, but perhaps we can use our little auto generate where we can handle the cases. And then now our problem is slightly simpler. We didn't know how to implement the response, but we know the response is one of two cases. And so we use structural recursion to deconstruct our values and handle each case separately. And then we start filling in the question marks there. So that's the basic idea. It's not very complicated, but it's very useful, and I'm sure you've done part of it. So I just wanted to show that technique. Try it out, put some question marks in there, define some abstract types, some type parameters. You don't know what they are yet, fill them in, and maybe that can sort of lower the cognitive burden of programming. Programming's hard. This might help you make it a little bit easier. That's all I have.
Oops.
Yay. Thank you. I'm early.
Yes. Thank you, Adam. That is one of those important techniques that a lot of us who do Scala a lot do all the time, and I don't think we talk about it enough. So it's great to have it.
Yeah, gotta talk about it.
Written down so that folks can know to do this when they're starting out.
Question mark. There we go. Use that thing.